Today I'll be talking about DementiCare, an application to complement caregiving for dementia patients. So before I dive into the tech part, I would like to give some background and talk about my friend Jack. His father had dementia, and I remember him being completely stressed all the time. He had to shuffle between his 9 to 5 job, taking care of his father, and managing his own personal health. One day, he came to my house quite worried. His father had left for a walk but not returned, and turns out his father had lost the way back home and could not understand how to contact him. We had to search for hours, and this left a deep impact on us. Turns out, Jack is not alone. There'll be an estimated 152 million dementia patients by the year 2050. Aging is the strongest known risk factor for dementia, and over 1 in 5 people will be over the age of 65 by 2050. To make matters worse, an estimated 71% of those patients will be in lower income countries, having less access to resources, skills, and finances for caregiving. The exorbitant cost of caregiving only aggravates the situation. Given how widespread dementia is, one would expect the presence of caregiving assistant tools. To give some context, over 50% carers say that their health has suffered due to caregiving responsibilities. And during our talks with patients and their carers, we understood that most patients spend their time on some sort of electronic device. However, there's a tech gap, and no apps exist to actually complement caregiving for these patients. This reduces productivity, accessibility, and efficiency of caregiving while making it tough for non professionals with those skills to nurse their loved ones. Thus came the need for DementiCare, the first two-way interface for caregiving. It provides an immersive and scalable platform for connecting patients and carers from a single application. Now that we have some background about DementiCare and dementia, let's dive into the technical details. So, DementiCare is achieved by creating a feature-rich caregiver interface and a simple yet engaging one for the patient. We used Flutter to develop the application, mainly since it allowed us to develop a cross-platform application with ease. And there were a bunch of useful plugins in Flutter which helped make our development process easier. We used Google Firebase as a cloud platform since integration with Firebase is really a breeze. As with every project, there were a few challenges we ran into while developing DementiCare. Today, I'll be talking about some of these challenges, such as the design considerations we took to provide an engaging interface for the patients and the carers, how we handle the flow of information between the carer and the patient, and how we made use of sensors in the patient's phones for fall detection, proximity sensing, and providing relevant information to their carers. I'll first talk about the design considerations while developing DementiCare. Since we aim to provide a single platform for patients and carers, this means that we need to provide different views for the patients and the carers from our application. During our talk with carers, we realized that the biggest challenge for us would be to make it simplistic and intuitive for the patients so that we don't confuse them while keeping it feature rich for the carers. So the first challenge for us was to accomplish this from a design standpoint. How do we allow for a single app to provide differentiated experiences for the carer and the patient? The solution was selecting roles during their first sign up. So when users first sign into the application, they're prompted to select a role between a carer and a patient, which is consequently stored in Firebase. Then, based on the role which the user selected, they'll be shown respective views when they open the application. Here I've attached a snippet of code which can complete this functionality. So during the first sign up, you can see a button here which in Flutter, and it will refer to the database and check the patient collection to see if the user is already in the application or not. If not, they're saved as a patient in the patient collection and taken to the home page of the patient. Whenever the patient opens the application next time, they'll directly be shown the patient side of the application, and similarly, something is done for the carer as well. Now that we know about the different views of the carer and the patient, I would like to take some time to demonstrate how the design languages change for the patient as compared to the carer. So here we can see the personalized dashboards for the carer, and they have access to a large variety of features and services like tracking and geofencing patients, sending urgent notices to them, and accessing their data like large proximity to the device, location and IMU data, and unfinished tasks by the patient. Combined with utility and productivity features like taking notes, reminders, calendar, and a dedicated chatbot, we've tried to provide them with a whole suite of features to take care of patients. So as you can see, Flutter made it really easy for us to develop beautiful UI and animation for the users. Moving on to the patient side, you can see it's relatively much more simplistic and intuitive. We have color coded buttons, and we generally aim to engage the patient rather than make them do work. So they can look at their family members, play memory games, record memory of everyday lives like a scrapbook, and look at the notices sent by the carer. Most of the heavy work, such as patient activity information, crash detection, fall detection, are done in the background to remove patient input as much as possible. I'll discuss more in the coming sections. So now that we have discussed the different views of the carer and the patient, the question naturally arises as to how we allow the flow of information between the carer and the patient. This becomes especially important since we have to account for the fact that one carer might be handling multiple patients, which is really quite common in shelter homes, and also that one patient might have multiple carers, which is usually the case in family based caregivers. So, how do we allow for the scaling of patients and carers? The solution is that we create a mapping of carer to patient as a collection in Firebase to record the patients under each caregiver. For example, as you can see here, this is an example of a carer document which records the information of the patients under them. This will come under the caregiver to patient mapping, and each document records the addresses and the details of the patients under the carer. We do this in Cloud Firestore on Google Firebase. In a nutshell, we can imagine three broad collections being used for handling our information. The information of the carer is stored as a document in the caregiver collection, while all the patient's data is stored as a document in the patient's collection. The mapping we showed before can be used to send out notices to the required patient or retrieve data from the patient and act as a middleman. For example, we create documents in Firebase to record notices sent by the carer and also to extract the data from each patient. As we have already shown in the screenshots, each carer can now add any patient under them without having to depend on other carers taking care of the patient or requiring a complete overhaul of our database. We simply record a document for each carer and maintain a collection of patients which are under them. Now, whenever a carer needs to access a feature such as tracking the patient, we use the patients registered under them to allow them to select who they want to track. And once a patient has been selected, we can get the details from the Firebase. This piece of code can demonstrate what I'm talking about in more clarity. So this is basically a function to create a record of the patient whenever a caregiver registers one under them. So during the first registration, the carer can simply add the patient's name, their email address, any existing medical conditions, and the SOS contact of the patient. Once the user submits this information, we call the document containing the carer's caregiver patient mapping on Firebase and set this information to register the patient under them. Next, we also add the caregiver's information into the patient's document, and this is separately maintained in the patient's collection. Thus, the patients are created whenever or updated whenever a carer registers them. So as you can see, this chart can easily demonstrate what I'm talking about from a technical standpoint and an implementation standpoint, which is that once this has been done, accessing any patient's information becomes quite easy. For example, the carer enters the track feature, selects any of the patients under them, and once it's selected, we can use the mapping to obtain and render the patient's location from the document. Now, finally, I would also like to talk about some of the heavy work we did in the background, which is quite important because when we were talking to organizations, carers, and patients, we understood that patients get confused very easily. We cannot expect them to manually inform their carers if they get lost, have an accident, or have completed a certain task. So, we make use of the sensors in the patient's phone to monitor their activity and trigger SOS calls. Additionally, we also store information about the patient, which we think might be useful for the carer. For example, their battery level and their last proximity to the device. So, from a technical implementation standpoint, I would like to discuss how we set this up in our application using some awesome and well-maintained plugins from Flutter. Broadly, we can divide our background processing into proximity sensing, fault detection, and patient monitoring. This chart represents the plugins we use for each of these processes, as well as some dummy code to get us started. So as we can see from our patient's phone, for proximity sensing, we used a plugin called Proximity Plugin. This plugin can actually listen to events whenever the carer is close to the proximity of the phone, and there are actually sensors in phones which can detect this. And once we listen to such an event, we can update it on our Firebase, which can then be consequently pulled into the caregiver's dashboard. Going into fault detection, this is a two-way process where first we use the shake event plugin, which makes use of the sensors inside the patient's phone to listen for any kind of false or massive shakes of the phone. And we can also trigger the parameters of these and thresholds of these sensors so that we have an accurate detection. And once we actually listen to some event like this, we can use telephony, the plugin, to send an SMS as well as call the patient automatically without the patient's input. Finally, to monitor the patient, we used Flutter background geolocation. This not only allows us to track the patient in the background, but also access to some of their activity details, like whether the patient is walking or on a car, and also if the patient has uh, you know what the battery level of the patient is, and so on and so forth. So moving forward, we realize that the need for tech-based solutions for caregiving will only increase with time. Thus, we want to take DementiCare forward and make it a useful tool for caring for dementia patients. Our goal is to work with real-world carers, patients, and network with professionals to actually build a product which is useful for society. We want to keep developing, adding new features, and refining the ones we have, and hopefully do something good for society. We are already in talks with some organizations like Alzheimer's Disease Association Singapore, some shelter homes, as well as healthcare organizations to collaborate and obtain feedback about what we have built till now. We recently emerged as winners in the Google Solutions Challenge, and their mentorship actually really helped us take DementiCare to the next level. While there were many more challenges we faced during our implementation, I tried my best to explain the gist of what DementiCare is all about and how we went about solving some of the core challenges we faced. Hopefully, this will be useful to developers and students around the world. And if you'd like to talk more, you can definitely hit me up. It was a pleasure to give a talk at La Kopi, and I hope to work on more such impactful projects in the future.
Okay, the very first question is that was the focus to always develop the Medicare as a business, or were you just focused on making the tech possible when you began? What was your approach to this?
Okay, so I would say that initially we started off as a pet project. It's something that me and my friend wanted to do together because we noticed that this was something which would be useful to people. And as we went about developing it, we started reaching out to organizations and trying to get their feedback on what we have built. And as we went deeper and deeper into the development process, we started to realize that this was actually a project that could make a difference in society. And especially once we got into Google Solutions Challenge and we started receiving mentorship from them, we realized there is definitely potential here. So that is when we started to take things more seriously.
So we also have another question. The next question is this: how did you convince user adoption? Could you explain the process and give specific examples about the departments and the group of people you approach and training you had to do?
Okay, so about user adoption, we are currently, in the phase where we are talking to patients, carers, and organizations about how we can make dementia care better. So in that regard, I think the what we actually did was try to build a project or a product which was useful to them, and we were actually presently surprised at how many organizations and how many people were willing to adopt this. So once we started talking about these kind of things, and especially when we started receiving some mentorship from our professors who we approached, and going into competitions like Solutions Challenge, who provide mentorship to developer projects, this made it even easier for us to target what we wanted to do and have a very concrete approach about it.